Warning: sodium hydroxide is highly caustic. Hot sodium hydroxide and hot oil can cause serious burns. Do not repeat this experiment. Whenever somebody else is doing all the work, there's always some jerk-off who asks a stupid question. Today, I found that was me. Don't ask dumb questions if you know what to do. Just find out for yourself, if you're able. This experiment just requires measuring things out, boiling things up, weighing things, and perhaps measuring temperatures. Oh, and a little bit of maths as well. And if you're lucky, you might win a banana. In this experiment, I'll be using some mineral oil in the form of baby oil, some sodium hydroxide, a beaker, and some scales. First, switch on your scales. Then switch them on again if you've accidentally turned them off because they're already switched on in the first place. Then measure out an arbitrary quantity of sodium hydroxide, in this case 16.15 grams. Next, tear the scales, take off the safety cap that's child-proof on the... oh god, get an adult to help you if you need it for this part. Then measure out an arbitrary quantity of the mineral oil. As I said, in this case it's baby oil, and for this experiment I'll be using 31.6 grams. Next, it gets put on the hot plate and the heat turned up and the timer started. Just for the interest, I'm adding a thermometer, although it's not strictly necessary for this experiment. It's worth noting that it's not a good idea just to dunk your thermometer in there and leave it lying on the bottom of the beaker. Better to rig up some kind of stand so that it's suspended within the liquid but not quite touching the bottom. As you can see, we're already up to 140 degrees centigrade. Now all I have to do is wait. And wait some more. At 10 minutes I think I got a bit bored. So it's a good plan to have something else to keep you occupied while you're waiting. I like to chuck in little balls of aluminium foil into heavy metal chlorides. They make a lovely fizzing noise. Fizzy, fizzy, fizz, fizz, fizz. Oops, back at the experiment, we're past 190 degrees. I think that's probably bad enough heat. They say boiling hot oil and hot hydroxides are dangerous, but I'm just pulling this sash down because, well, it's might as well, it's just there, isn't it? Now the experiment's had at least 10 minutes more to cook, there should be some measurable difference if anything's going to happen, so time to take the beaker off and put it on some kind of flame-proof block. Easiest way to make this is just to torch a piece of wood, I find. The beaker and contents are far too hot to handle safely, so it's best to let it cool down a little bit. Well, it's cooled down a little bit, so let's stick on something to seal the top. We don't want atmospheric moisture getting back into the mixture. Well, it's starting to look cool enough at about 25 minutes, so let's see. Yep, that looks okay to me. I can handle that. Now it should be cool enough. More to the point, I don't really want to destroy the scales just for the sake of waiting a few more minutes for the mixture to cool down to something safe. And the final result is about 158 grams. So, I earlier measured the beaker at 110.65 grams. Then there was added the sodium hydroxide, which weighed 16.15 grams. And then the baby oil was added, 31.60 grams. Add it all up and we end up with 158.4 grams. Well, the final beaker weight was 158 grams, so What's the weight loss going to be? Yeah, I think about 0.4 grams. So, there we have it. If you can do it yourself, just do it. Don't go expecting other people to put in the hard work for you. For those interested, there were no beakers harmed in the making of this video. That beaker was hardly a new beaker, and there was no discernible extra damage to it after the experiment. Thanks for watching.